In this lecture, I'm going to cover the basic I/O concept and the stream class. Stream class including the input stream and output stream. Basic I/O concept. We have a data source, and then the program wants to read the data from the data source. We have an input stream, and then data being represented in the binary format to be read into the program. And for output, we have a program we try to send the data in binary format as a string, we call it output stream, to the data destination. It could be a printer, could be a computer storage, could be a monitor. Text I/O and the binary I/O. Text I/O program. Basically, the program needs to read or write the data in the text format. Usually it is in Unicode or ASCII code format. So you need the encoder and decoder from the storage to the program. And binary I/O program, basically you are trying to read or write data based on the byte unit, not by the symbol or character as the text I/O. In the past, we had the bit serial devices, but because the memory cost has dropped so low, right now we don't need the bit serial devices. We only have the byte devices, and sometimes even the storage has been upgraded to the block by block or sector by sector devices. Stream I/O. We had two types of stream, character stream or byte stream. Character stream, we use reader or writer. Basically, you are reading a character or some text. The name is reader or writer. Byte data, it is in binary format. So we have the input stream or output stream. See, the data is like a stream, like a river. It keeps flowing in or flowing out. So it is like a stream. So the program can have the character-based or byte-based, and then you write them or read them. The input source can be keyboard file, network, or program. Same thing for the output. You have the console file. Console is the terminal. File, network, or program. And the format could have ASCII, could have UTF, or Unicode, or ISO standards. And binary usually is in raw byte, so each one 8 bits. String class to handle I/O. Java string class has two types. One is character string classes. The other one is byte string classes. And character string can have the reader class and the writer class. And these reader or writer access the memory file or pipe. The string class can be characterized into two types, byte string and character string. The input string, output string class is the root of all byte string classes. And the reader-writer class is the root of the all character string classes. The subclasses of input string, output string are analogs to the subclasses of the reader and writer. Now let's look at the input string and output string first. Input string and output string are used for the byte data or byte string. It is for the binary I/O, and we may have another one that is the random access file. We will have a special lecture focused on this. And for input string, we have file input string, pipe input string, object input string, stream buffered input string. And file input string have data input string, buffered input string, line numbered input string, something like that. And similarly for the output string. It's just one to read data in and the other one to write data out. And for reader and writers, they are also strings, but they are readers for text or characters. So they have the input string reader, buffer reader. As you can see, the name is similar to the input string classes. The only difference is wherever there is a string, now replaced by reader, and same thing for the writer part. Input string versus reader. The reader class is similar to the input string class. The methods in readers are subject to character interpretation. Input string you have read array of bytes, close, available, and skip. Similarly for readers, but there is only one difference. The reader don't have the available method. And if any of them break, you will have I/O exception. And there's another difference is the reader is character-based and the input stream is byte-based. And both of the classes are handling keyboard, file, network, and program. OutputStream versus Writer. Similar to the InputStream versus Reader. And the difference is on the format of the data being read in, and the methods are the same. Data cook level. The word cook for us means how mature the data is. It can be rare, or sometimes we call it raw data, or well done. Say data source, we have a file. We try to read the data byte by byte into the Java program without any interpretation, that's using InputStream. And then we can also put a reader after the string so that we can read in byte, but interpreting it as characters into the program. So as you can see, reader and InputStream actually can work together. Another level is we read the data by byte in, and then we interpreted the data and send it to a certain buffer, and after the buffer we read into the program. Because the buffer size can make sure that data is ready, so the program won't stop. It will keep supplying the program with the buffer data. If there is no buffer, then the program has to hang to wait for the reader. So a buffered reader prefetch character into a buffer for performance purpose. Processing external files. You must use file stream to read from or write to disk files. You can use file input stream or file output stream for byte stream, and you can use file reader, file writer for character stream. As we mentioned, the input or output can have input stream or output stream, and each stream may be accessed in file, memory, or network or keyboard. For file itself, we can put a file in front of the input stream that is a dedicated input stream for files. And there are several different names for the input streams. And right here, we mentioned about its file format. And for the reader writer, similar to the file input stream, except that the data format is character. File I/O stream constructor, constructing instances of file input stream, file output stream, file reader, and the file writer from file names. So we put a certain file name and we create a file handler in file or output file handler out file, something like that. And we can actually build up a convention of using similar name for input stream or reader, because by doing this, you don't need to worry about the input devices. And cooked scanner or print writer. Scanner is what we used before, and it is considered to process the well-cooked data instead of the raw data, similarly for print writers. Now let's look at the demo program, CopyFileUsingByteStream.java. Basically, this program will demonstrate to read in an image file called ECID3.png, that's binary format, and then read into the program, and we write it out to a ECID3 copy.png. Let's look at the program. The copy file using ByteStream is over here. Basically, we set up an input stream and an output stream to be null, and we try to attach the file stream into this file stream handler. So first, we will try this file input stream new file to open this ECID3.png file, and then we assign the handler to the FIS handler. And similarly, we open the output file and then assign that to the output stream. So if the file existed, then we print out that the output file already existed. And then we try to check the number of bytes available for the file. And then we start to read in data byte by byte. And then if the file not found happen, we will print out that the file cannot be found. And then we try to print out the message for the error. And finally, we will try to close the file whenever we finish doing the project. Let's look at the image. The PNG file for input look like this. The ECID3 look like this. Let's run the program. Click and run. So the file has 5,299 bytes. Let's look at the output file. The output file's name is ECID3 copy.png. Let's open it. It is exactly the same as the ECID3. So download this program and try out yourself. Have some fun!